Hi there. Thanks for showing up for your learning. Several of you have some difficulties working with rational functions and subbing in, and it has to do with working efficiently with fractions. So let me walk through how we would do that. In this case here, if I want to evaluate this function f of x when x is 1 over 3, that's asking me to sub in 1 over 3 for x. So I'll have 5 over 3 multiplied by what? Well, by the x, which is 1 over 3. I'm going to substitute that in there. I can substitute x into brackets wherever I do my substitutions, just for an extra layer of clarity. Then I'm going to subtract 7 from that, because that's what the original function asked me to do. So now, how do we deal with this? Well, we could do 1/3 minus 7, which would be negative 6 2/3, and then multiply that by 3. But an easier way would even be just to distribute that 3 in right now. So let's do that. 3 multiplied by here and 3 multiplied by there. So that's going to be f at 1/3 is equal to still 5 on the top. We haven't touched that. Over 1, because 3 times a third is 1, minus 7. Well, that's minus 21. 3 times negative 7 is negative 21, so we're going to have that. And so f at 1/3 is just simply 1/4. Let me show you why. Negative 1/4, that is, because f at 1/3 is equal to 5 over negative 20, which is a fancy way of saying negative 1 over 4. Okay, so that's the final result. Now let's check it in Desmos. Let's do that, folks. Let's check our answers in Desmos. Let's have this habit of checking our answers in Desmos because we want to get all the points. We want to get everything right. And we're having trouble visualizing these things because a lot of them are really new and summer school comes fast. So use the shortcut of just see it in Desmos. So this was, what did I say? 5 over 3 multiplied by x minus 7 in the bracket. There we go. Now we wanted to know f at 1/3. Is that right? F at 1/3? Let's see. What did I do? Yeah, f at 1/3. Okay, so to see that let's let x equal 1 over 3. And that gives us all the places where x is 1 over 3. And look at that. Negative 1/4. Whee! Negative 1/4 is correct. So we're very happy. Very, very happy. Now, what if I did the crazy thing of asking you to evaluate this where f is 7? What then? Let's find out. If f at 7, and we want to evaluate this is 5 over 3 times 7 minus 7. That's substituting in there for x. But 7 minus 7 is a fancy way of saying 0. So you have f at 7 is equal to 5 over 3 times 0. That just looks so weird to me that I'm actually doing this algebra. Is equal to 5 over, it looks so gross. 5 over 0. Okay. What? Is that 0? No, that is not 0. That's very definitely not 0. This is what we call undefined. We can't divide by 0. That's like saying I have 5 pizzas and 0 people are going to eat them. How many pizzas will everyone eat? Huh? Okay, that's like saying I want to cut these 5 pizzas into 0 slices each. But they're each already 1 slice. So how do you cut it into 0 slices? It doesn't make sense. All right, so it doesn't make sense for a lot of different reasons, especially when we imagine pizza. And when we look at the graph, that's confirmed. Because if I say, well, let's let x equal 7, that's this line. That's the vertical asymptote. That's the line that the function will approach but never touch. Never touches that line. It approaches negative infinity in one direction and positive infinity in the other direction, but it will never touch. Okay, so is dividing by 0 equal to infinity? Well, no, because it goes to positive infinity this way and negative infinity that way. So how could it be this if it's 2 different things in 2 different directions? How could it be a thing? This is why it's called undefined, because we just don't deal with dividing by 0. Okay, so I hope that was useful to you. And any more questions, hit me up by email. Bye.